Not sure if you remember there, I got a layer. Oh, it's almost this one. I was good. Yeah, this one. This layer. So this is a layer that I have added in order to add some extra details, because I thought it was a bit not enough. So yeah, I like those kind of droplets. And this is what this one is doing. I'm just using the white water source here that I plug directly to the cache with the fluid compress, and then create some particles from it. Let's refresh the view, the scene view, using the source particles and setting here the voxel size that I was using inside my flip solver. And I thought this amount of particles was good enough. Same thing, it creates an emit volume that I don't need, so let's delete it. Alright, let's optimize it by deleting all the things that I don't need, and which is everything in this case. And I just need to get the velocity. So I transfer it from the main simulation. Alright. Then I have something like this. Okay, this is the emitter. And let's dive inside this one. So same thing, the start frame is 12. And this is actually almost the same thing than the previous simulation with the flip solver. But the difference is that it's not a flip solver, it's a pop solver. I'm using 5 substeps in order to be accurate, and sourcing from the first input, all the points. I don't need to set a life, or 100 is good. I want to inherit of the velocity by 1. I'm adding the H frame directly. I don't need from an active or stopped attribute, because the source is emitting like not every frame but almost. And here, this is important, I'm using the pop fluid node. This is very useful actually. I use it quite a lot. It might be a bit complicated, so I think that's a good idea to check this link. This is a tutorial for another guy, free tutorial. It's very well done. It's a 10-minute tutorial, so just check it out and you will know what to do with all those parameters. But once I'm happy with that, I just set a bounce and friction from a random function. Same thing here, I'm using security with the pop group that I'm looking with the bounding object with the collider, creating the in group, and if it's inside the in group, then I'm moving the position to the closest surface, and same thing, decreasing the velocity by 10. This is what I'm saying here actually. And same thing for the gas intermittent solve, because here I'm using 5 substeps. I don't want, for example, to iterate 5 times for the H frame, so that's why I want per frame and not per substeps. Okay, there is nothing special except the substeps here. The gravity is by default. The ground plane as usual, the static amphora, same thing. Nothing special. This is the same setup collider that I'm using for the flip, so this one. For the amphora here, I'm using the same output, but I'm not using the re-evaluate SOP to interpolate geometry. I think for this layer it's not very important, it's just an additional layer to get extra details. It's not the main, the most important one. So that's why, and that's it. So let's go back to the whitewater sim. Even if you understood, it's not whitewater, definitely not. But it's just because I'm using the whitewater source here. So I'm importing the pop with a dop import, deleting all the attributes that I don't need. Same thing for the group. Updating the velocity, because we never know, with the central difference to be more accurate, and then cache it. And this is what we have. Wait a minute, actually, let's see if I have the cache. Yeah, I do. Okay. Okay, good. So here I'm adding a couple of nodes that I don't need there, because the particles number is not changing here, but here it is the case. So first of all, I'm clamping the start and the end frame to make sure that I don't have an error at the frame 1 or 180. I am adding a p-scale, which is the same than my particle separation, and another attribute called simFrame. So this attribute is using the similar way, I'm using the similar way that we have seen inside the Introduction to Retime tutorial in order to make the slow motion particles work. Why I'm saying that, and I'm going to show you why right now. Saying that because, oh, it's not you, let's change, because this one. So this is the step 4, and we want the step 5. Actually, let's make it stop. And there. Okay, so this is the layer, the extra layer with the white water source. And as you can see, every 20 frames, it's adding new particles. This is because of the slow motion. There are a couple of ways to avoid that. In our case, we don't need to really change it from the particles, because we are not going to see at the end particles, but mesh. And the mesh that we are going to create is based on VDB, and then we have to modify the VDB creation in order to get here the step 5, so which is the same but with the mesh, something way more linear. If you check, it's a bit visible, the steps in between the particle creation, but not that much. And we have done that with the attribute, so this one, the add sim frame attribute. So what is it? It's just the frame attribute that I'm going to interpolate with there. You can say, well, I don't want any attribute except the one that the sim frame one. But in our case, we want all of them. But it means, for example, at the frame, if I check the geometry spreadsheet, at the frame 33, here my age frame, it's not 6, it's 6.446. If I increase, as you can see, it's like increasing to 7. It means that during this frame, so the frame 24, to the frame 43, I'm reading just one frame of my simulation. And if you remember, the speed is divided by 20, so that's why. But then I can use this interpolation to multiply my p-scale. So for example, if I want just the right part of this value, so it will be 0.9629, and then I multiply it to the p-scale. As you can see, if I go there, up, the p-scale is going to increase. So each frame, instead of having a pop, we will have linear growth of the p-scale. And this is exactly what I'm doing here. I'm just multiplying the p-scale by the frac of the sim frame. The frac is the fractional part. So in this case, I just take off the 6 and I get the value 0.41249. But don't forget that if I'm doing it there, each 20 frame is going to redo, and then we will have like a bouncing effect. And that's why I'm using the H frame inferior than 2. So just at the beginning, when it's just born, I'm modifying the p-scale with my interpolated sim frame attribute. Alright. Then here I'm using the exact same thing that you have seen here. So I don't have to explain. Oh, let's not compute it. It's going to be long. Okay. So nothing to add particularly. Yeah, same thing. Even though I tweaked just a bit the value, it was 3.5 and now it's 3. Let's go to the next layer.